okay, let's solve this LeetCode problem. You're given an array, and we have to remove a subarray from this array such that the remaining elements are non-decreasing. We have to find the length of the shortest subarray. Now, for example, in this case, we can remove 3, 4, 3, 10, and 4. So we can remove this 3. Then we'll have 1, 2, 2, 3, and 5. 1, 2, 2, 3, and 5. This is non-decreasing. So in non-decreasing case, AI is less than or equal to AI plus 1. So this is our array. So that is what they mean. And we have to remove this shortest subarray. In this case, it's 3, 10, 4, or 10, 4, 2. The answer is 3. So let's move on to the explanation. Okay, now let me show you how I approach this problem. I approach this problem in a high level first. Now let's think about an array. Let's think about this array, right? Now imagine that I remove all of this elements except this one. Let's call it A. Okay, now what happens if I have here a B such that B is less than or equal to A? So then I can, the B and A, so this is a non-decreasing array. This is a valid non-decreasing array. So why remove then B? So we can keep B and instead remove this subarray here. Right here. So we do keep doing this as long as we find some value here, C, which is less than or equal to B. We again include it in the non-removed part, and then we remove this part. So we basically shrink our first assumption that we remove this part. We only have A, and A by default is a non-decreasing array. So basically we keep doing it. We keep doing it, but as long as we have some array. So we have A, we have B. Let's say now we have reached a point, we have a C, where C is greater than B. Now we cannot include C. So for B and A, so BA in this direction is non-decreasing. But CBA is not. So this point is where we stop. So this is as far as we can go from the right side. So I'll refer to this as end array, end subarray, or end array. Now what I claim is that, okay, now remember that C is greater than B. Now what I claim is that there is another subarray, there could be another subarray here on this side that is non-decreasing. So we call it like this way. So there's a D. So after D, and there's an E, such that D, so this is non-decreasing. So D is greater than E. So we cannot take E because that would break the non-decreasing nature of this subarray. So after D, it's non-decreasing from this left side. So now I'll refer to this one as left as front array. So now we have D is greater than E, right? Now what I claim is that we remove everything. So I'll show you. We remove everything in the middle from E to C, inclusive. A and C also goes. So we remove everything E through E to C. So from E to C, this subarray here has to be removed. So this means that whatever the subarray that we'll remove at the end, it must include this subarray. So that is the claim. That is the claim that we have to remove from this. We found these 2 points, and between these 2 points, everything should be removed. So this subarray must be included in the final subarray that is going to be removed. So that is the claim. So now let me give you an sort of like intuitive proof of this claim. You might think, okay, maybe I don't remove actually the E to C. Maybe you keep some part of it. Let's say you remove, so you might say, okay, what if we have a non-decreasing array from this point, let's say in the middle of this range. so this subarray, to the right, right? So you have a non-decreasing array. Isn't it possible that I can remove, and I also have a non-decreasing array, we know that on the left side, right? Isn't it possible that I can remove this so that I join these two parts and to make it non-decreasing array? Absolutely, you can do that. You can remove this. If you think this, you're right. So you can remove this part from this E to up to this point. Then in the final array, yes, from this part and this part, it might be the case that it's increasing. So when you join, after you remove this, when you join D to this element here, it might be from the first to the C increasing. But the final array now includes C and B, where C is greater than B. This is not non-decreasing. This breaks the non-decreasing nature of this array. So it's not possible that we remove this part here and join from this part to the D. So it's not possible this way. And by the same reasoning, like without loss of generality, you can do the same for the left side. You can, let's say we have, instead, let me just clear this. Now we might have something like different. In this case here, you might say, okay, let's just say I keep this side from this point on. Isn't it possible that we have an increasing array from this part up to here, and from E to C we have an increasing array, right? Then isn't it possible to remove B? So you should remove this side, right? So then we remove this side from up to here, and from E to C it's non-decreasing array. It's possible that you think this, or from this E to C it's non-decreasing array, right? Then we have to remove B and A. Again, at the end, when you remove it, when you remove any part, if you remove this part from E to C, it's non-decreasing, but CB again is violating the non-decreasing idea. So this is not possible. Even if you remove anything, any value from the E to C, it will not be possible. So you have to remove all the values from E to C. Let me again clear and show another case. Now, if you might say, okay, let's remove. You might say, okay, from this part to this part, it's non-decreasing, and it could be actually the case. You might choose to a range like this, from here to here. Like the values could be in non-decreasing order, and you might say, okay, maybe this is the answer. This could be the answer, right? It could be actually long. So this might be the answer, but it is not, because in this case you have to remove all of these values, or these values, but you cannot do that at the same time. These are two disjoint subarrays, and we can only remove one subarray, so it's not possible. So once you check this claim with you, and make sure that we have to remove all the elements. Once we find 2 points here, I and J, so we go from the left side as long as we can go, and we go from the right side. We basically find the longest non-decreasing subarray from the right, and we find the longest non-decreasing subarray from the left. So I mean this way. And then these 2 points, let's call it I and let's call it J. So this 2 I and J is going to be the breaking point, and everything between I and J should be removed. They will be removed. How many elements do we have between these two? We have I minus J. It is, so we have to remove this element. And then what remains, okay, what remains at the end is 2 subarrays. So this is basically the suffix, or I call it like the end array, and this is basically the front array, the prefix. And both of this are increasing. So we have here D, we said we have here B and A, even you might have other values, right? Then what we do, if D, now we check, like you use some sort of like 2 pointers, we have D and B, right? We check, okay, if D is less than or equal to B, so then we can join this 2. We will join this 2, and this is going to be the array. If this is not possible, the resulting array, if this is not possible, it could be like D might be greater than B, or like, then we either remove B or we either remove D. So in this case, we find, if it's not possible to join them, we find such place in this 2 array, such that we remove some element from here and some element from the front of this array and the end of this array. So we can do this with the binary search. For example, for D, let's say, okay, the last element that is included from the first array is D. Then then we have to find an element in this array, let's call it B, in B, such that it is greater than or equal to D. And then we will remove everything from the front of this array up to this found element, and then we can join the remaining parts. And then we can check every other elements for, from the first array A. So let's say we have in here E, and we can check this for E. Let's say the last element from the first array A is going to be E, so that means we remove D. So then we find the value from the B array that is greater than or equal to E, and up to that element we remove every element. So that is going to be the number of element that we removed, and then we add this to the result. So our previous result, the previous result hold the values that we remove, that between E and C in our previous case. And now we add other elements to the result, and this is going to be the final answer. Now let's move on to the code. Okay, this is the code. Now here I do a little bit of checking. First I have this variable, the flag. That's basically, I use this to check if the array is already sorted. If it is already sorted, I'm just going to return 0, because we don't need to remove any element. Otherwise, we found the I and J that we said, okay, there is going to be a breaking point. This is going to be an I and J. At some values here, this is non-decreasing, and some values here, this is also non-decreasing. And we claimed and proved that everything here should be removed. So everything here, we remove it. So we found an I and J. So basically, I is the longest non-increasing prefix. We find it here. And the J is going to be this point. This is the longest this is not non-decreasing, but it's increasing since I'm looking this way. But if you look this way, it's going to be non-decreasing. And then we find the J. This 2 is here. And afterwards, we have, okay, I have a little log statements here, just to make sure. I use logging to debug. And then after that, we have the result. This is the claim. Basically, we remove the J minus I minus 1 elements that are between I and J in our array. So we remove all of this element. And then we have the binary search. We do the binary search here. We find the minimum number of elements that we have to remove after we have the array B, let's call it B, array A, and let's call it array B. And this is the prefix, and this is the suffix that we found. This is basically I and J. And then we start here. We say, okay, what if this element from the A array is not removed. So we have to find the first element in B that is greater than or equal to X. So after, let's say this is Y. So after this element, everything has to be removed. So then we do it here. So we found it, and this is the number of element that we have to remove. Or is it possible that we're removing an element A here? So then we have to find the first element that is greater than or equal to A. Let's just say it's Y. So everything from B up to Y should be removed, and we have to remove everything up to, so down to A, from the first array. And this is going to be the number of array, the number of elements that we remove, and we find the minimum number of elements that we remove in such a way. At the end, we're going to add this to our previous result. The previous result is this one, the one that we remove from the middle to get A and B. They always get removed. So that is basically the algorithm. So what we do, we find an I and J. This is, at worst, is an O and N. And then we have, on one side, we do binary search. On one side, this is B. On A, we do one by one, we check every element. And on this side, we do a binary search. This is, let's say, of log n. And for every element on this side, let's say we have n elements. And then this is going to be end up O of n log n, which is pretty fast. So that is all. I hope you found it intuitive. This time it was a little bit messy, and I hope you understand. See you in the next videos.